Hi guys, today we are going to do some more factoring, but today it's going to be with some special cases. Today's a lot easier than what we've been doing so far. So I'm going to go ahead and start off. Our first example, we're going to use n squared. You don't always have to have x. I'm not going to use x today, I'm going to use n. And before I do this one, I'm going to show you the first way I showed you guys when we first started doing factoring. So if you look back in your notes, when a is equal to 1, and this is the one I'm showing you right now, we used the AC method, the factoring method, and the two numbers you found, you put them in and you were done. And so anytime a equals 1, the two numbers you find, put them in and you're done. The notes we did before this one is whenever a is greater than 1, the two you find, you put them in, but you have to continue on all these steps, factoring and doing all of this. Now this method will still work on today's lesson, but it's really long and there's a shortcut, so I'm going to go ahead and show that to you. I'm first going to show you that you can use the way I first taught you. So the way I first taught you is identify A, B, and C. A is always the one that's with the variable that's squared, so this would be a 1. B is always the one that is with just the variable, and that doesn't exist, so it's 0. And C is the one that doesn't have a variable, so this is -9. So when you do the AC method, I'm going to make some room because I'm going to do some work over here. So just let's first do this. And I'm going to put the AC, the diagram here to leave some work here for the shortcut. So A times C is on top, B is on the bottom. A times C is -9, B is on the bottom. What can we multiply? Whoops, it went in the wrong spot. What can we multiply that makes -9? But when we add it together, we get 0. Well, 3 times 3 makes 9. And either one is negative, and when you add them, you get 0. And so if we do it this way, these are your two answers. And you can just put them straight in. So -3 here, and a +3. And the first one is going to be, to get n squared, it needs to be n times n. Now this is pretty easy, but what I want you to do is recognize a pattern. These are, 9 is a perfect square, and the square root of 9 is 3. And in order to get 0 for the middle term, so anytime you're missing the middle term, and this is a perfect square, there is a shortcut. Let me show you how it works. All you do is you take the square root of 3, and the square root is always either a positive or a negative answer. That's supposed to be 9, sorry. And that's your answer right there. So instead of doing this method, you could just take the square root of 9, which is a positive or -3, and you already have your problem done. One's a +3, and on the other side is a -3. And that's how you get a 0 for a middle term. Pretty easy. So let's do another one with just the shortcut. So what is the square root of 25? It's a perfect square. It's either going to be a positive or a -5. Now I do have to say one more thing. This will only also work if this right here is a subtraction sign. This will not work on addition signs, because if I wanted to make it a +9, you would have to have both of these negative, and when you add them though, you want to get 0. So that's why it only works if this only works if your sign is a subtraction sign and this is a perfect square. So you can always start with in here, in here. One's a plus 5, one's a minus 5. Pretty simple. This also works if you have so I should probably make a couple extra notes on this. So if you notice here, 16 is a perfect square. And 100 is also perfect square. Since this number is greater than 1, the notes we have will definitely work, but it's a lot of work to get to our answer. And I really don't feel like going through all of these steps when I have a super shortcut to do. So if you notice that this is a perfect square and this is a perfect square and this says to subtract, that's the only way this will work. Okay, so this is actually a perfect square because the number in front of here is a 1. 25 is a perfect square, 1's a perfect square, -9's a perfect square. So it will only work if you have perfect squares and a subtraction sign. And to do this, all you have to do is find the square root of 16 and the square root of 100. Okay, so here's the trick. Square root of 100 is a plus or minus 10. And the square root of 16, although it's a plus or minus, because it's the leading term, we will always put it as a positive. So the leading term always has to be positive. So when I write this, you're going to have square root of 16 is 4n. So 4n repeats itself here and here. And then in these two spots, one will be a plus 10, one will be a minus 10. This pattern is the same every single time. If you want to check and make sure it works, you just have to multiply 4 times 4n times 4n is 16n squared. And then if you multiply times -10, you get -40. And then on the inside, you get +40. So those cancel each other out. And then the last two, multiply them and you get -100. Let's just try one more and to make sure you guys have the hang of it. Let's do 4m squared minus 81. Go ahead and pause it, see if you guys can do it, and then unpause it and check for the answer. So hopefully you got the square root of 4 is 2, and we're going to keep it a positive 2 because it's the first leading number. And when we multiply them together, we have to have the first number positive. The second number, square root of 81, we're going to do a positive and -9 to get rid of the middle term. So when you write your answer, start with 2. Don't forget the m or x or whatever variable it is. Pay attention to that. This one starts with the same thing. And then we're going to put 1 as a plus and 1 as a minus. Order does not matter. You will still get the same answer either way. All right, guys, hopefully that was easy today. You are done with the notes and you are ready to begin the homework.